I may be a bum, but I'm not dumb. It's time for Bum Knowledge Corner. Hello, YouTubers. I am the Car Bum, and this is my corner. That place where I jump on the hood of your car and wipe down your windows with spreadsheets. Today we are going to talk about multiplications. As you can see, here's a basic times table. And I'm looking at this today because of a YouTube video that I saw a while ago done by this man. His channel is called Combo Class, and this one was released October of 2023. And it has just a and along his things, he was talking about how like math should be or the like you should only really remember 1 through 9 multiple tables, and just also just know the patterns. He explains it better, but he also has this thing called almost square or near perfect squares or something like that. And the overall concept is when there is a perfect square that is highlighted in blue, that anything that if a number is separated by one higher on one side and one lower on the other one, it will always be one less. So if you can see here, this is one less. And 100, 99, 81, 80, 64, 63, and so on and so forth. Now, I was actually wondering what would happen if you went even further, and so I made my own little chart, and I noticed that as you went away, it was -1, -3, -5, -7 from the original number, or from each. So this one is -1 of this. Then if I -3, it's that. -5, it's that. -7 is that. From each step. But then I kind of thought about it again, and it's actually -1 from the main number, -1, -4, -9, -16. So it's actually decreasing by a square. So we have this square going this way, and then when you go in the other direction, it is decreasing by a square, which I thought was pretty interesting. The other near perfect square is highlighted by the red. This one, the pattern is a little bit different. It is actually n and then times n plus 1. So we have here 2, 6, 12. So 1 times 2 is 2, 2 times 3 is 6, 3 times 4 is 12, and 4 times 5 is 20. So that's how it works when you are on the red one. And with these two facts, you can actually calculate numbers starting high and then reducing it over time. And that everything. And like I said, it's just a neat little trick. And then I started to wonder why exactly it worked like that. And so and to show you how that works like that, we have this right here. Now I'm going to start with a number that's very simple, and that number is going to be 10 by 10. So you can see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and as you can see, we have a 10 by 10. Now, what we're going to do is remove the final row. Then we're going to put the row on top of it. Now we have 11 by 9. And as you can see, there's one that is no longer in the stack and would just fall away, kind of like Tetris. I don't know. So this would just fall off. And as you can see, there's 1. So removing that and putting it on top causes it to 1. If we remove the second one, it now also is added up to here, and now 4 are removed. So you can see the same pattern. Every time one moves from here to here, it removes the square going all the way out. Now you may be wondering, okay, that's kind of a neat trick, but how is that going to be useful? Well, since it's a consecutive and consistent, we can do things that we couldn't do before. Like, let's say you had a math problem, and the math problem was 25 times 15. Now, most people do not know what 25 times 15 is. It's just not one of the multiplications that people are familiar with. But we do know most people, even if they don't decide to remember it, do know 20 times 20, which of course is 400. And then we also see that this is 5 apart, because remember, you have to be 1, 2, 3, 4, 5, and then 1, 2, or is, yeah, starting for here, it's 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay. Or yeah, this would be 1, 2, 3, 4, 5. There we go. Starting with this one here. Now, I could have done the same thing starting from 100, but it's always the same. It went over by 5 and it went down by 5. So it's 25. Okay, cool. So with it being 5 off, we now have 400 minus, I did not say the entire, oh. Excel. 25, which of course is 375. And these type of things you can do anything. Obviously, this is less useful the wider the spread is from one to the next, but it's still, so if you had like, you know, 25 times 685, even though they would have a central point, it would be really far off, and it would probably, and then you would have to figure out the calculations between these. So it's not a universally useful thing, but if you have things that are close together and you don't know them at all, then you wouldn't want to, or then you would be able to do it more in your head. Let's this one I've done a few times just because I was thinking about random numbers. But let's But we have like, let's say you didn't know what 7 times 12 and 13. Aha. 13. Well, the center point of that, of course, would be 10. So it would be 3 away. So we have 10 times 10, which is, of course, 100. 100 minus 3 on both sides. So that would be minus 9. So 91. And just to do it, we could do 7 times 13. Boom, 91. There we go. So, yeah. It's usually just, you can actually do it for even, it does work for any number, even if they are the center point, even if they are different. Like, let's say this is 12 instead. That means it would be 9.5. And I don't know why you would want to do it from there because most people don't know that square anyways. But 9.5 what would be the other number? I am putting myself in a predicament right now, and let's just hope that this actually works. Otherwise, I'll have to cut it out because I'll be wrong. 9.5 squared, so that's 955, and then you would and then you would subtract 2.5, right? Yeah, 2.5 squared. So 2.5, or gotta put that equal sign in. 2.5 where and then you would just subtract the 2 equals u minus u, boom, 84. And 7 times 12 is indeed u times u, 84. So it does work, or even if the part in between is actually only half done. Which again, not too bad. And yeah, that was it. I just wanted to show this a cool little trick. Because it seems like something fun to play with. It is good for mental math. Like, I really put myself on the spot because I used a number that's not actually a square. That's not easy to square. Um, hmm, interesting. I'm just looking at this like, okay, so it's bigger than 9 times 10. That's interesting. Maybe I can figure out something with that later. But probably not. Um so yeah. That's it that I have. That's all the stuff I have right now. Just delete all those things because this is my notes. So yeah. I'm the car bum. Now get off my corner.